Hey guys, just listening to another song about home. My new tagline is home is wherever I do math. So here I am doing math. 5.3, notes. Sorry I'm not in school today, but we are going to quickly go through our notes. This lesson I think you guys are going to enjoy. Let's get to it. There are two identities that you guys need to know about. And we call this the sum and different identities for cosine, okay? Now, there are sum and different identities for sine and for tangent, but today we're just going to focus on cosine. And these are different than the identities for sine and tangent, obviously, okay? So the first thing to take note of in this situation is that when we talk about A and B, we are talking about two angles, okay? So angle A is angle 1, and angle B is angle 2. All right? And I'm going to give you guys the formula. It is cosine of angle A plus angle B is cosine of angle A times cosine of angle B minus sine of angle A times sine of angle B. Okay, so let's talk about this. So the way I remember it is cosine of A plus B is cosine, cosine, sine, sine. All right, so it goes in that order. And the biggest thing to remember that I think a lot of kids forget is that in between these two is a minus. Originally, okay, there's a plus. We're adding the angles, but in the formula, it switches to a minus. And you guessed it, the opposite's going to happen for the next one. So for the next one, we have cosine of A minus B. Again, these are two angles. We have angle 1 and angle 2. And just like you guessed, this is cosine of A, cosine of B, plus sine A, sine B. Okay, biggest thing to remember is that this minus is a plus in the formula. Okay, so that's the biggest thing that you really need to remember. But guys, the good news about this, okay, is that it's just a formula. And I'm going to show you a bunch of different examples of that formula and how to use it. One thing that we need to recall for this section is how to find cosine and sine of some unit circle angles. Okay, so recall. We need to know sine and cosine for angles such as 0 degrees, 30 degrees, 45, 60 degrees, 90 degrees, and so on. You need to know your unit circle still. It's back to get ya. All right, so just as a reminder, 30 degrees, that angle goes root 3 over 2, comma 1/2. So cosine of 30 would be root 3 over 2, and sine would be 1/2. For 45, it's root 2 over 2, root 2 over 2. And for 60, we have 1/2, comma root 3 over 2. We're going to recall that and try to remember those as we go on. If you need to remember, 90 degrees is at 0, 1. 1, 0 for 0, and so on and so forth, okay? So these are things we're going to kind of fall back on. So here's the deal. Because of this formula, I can use my unit circle and this formula to find cosine and sine of obscure angles that aren't on the unit circle, such as cosine of 15. Now, if I can create the number 15 using other angles that I know from the unit circle, okay, then I can apply the formula and I can calculate the cosine of 15 degrees. What the heck is she talking about? This is what I'm talking about. Oh, Okay, that's not going to work, so we're just going to kind of go back. Uh-oh. See, this is where this app gets me. We're just going to write small. No big deal. Okay. Do you guys agree that that 15 is equal to 45 minus 30? And even though I can't hear you, I can see you all nodding. Creepy. Because 45 minus 30 is 15. Now, I have rewritten this expression in the format of my two formulas, and I can apply. This is a subtraction problem, so I'm going to apply the second formula. What this means is that I can write this out, since it's the subtraction of two angles, as cosine of angle A, which is 45 degrees, times cosine of angle B, which is 30 degrees, plus, remember, it's a plus here, sine of 45, that's angle A, and sine of 30. That's it, guys. Now we just have to recall. Sorry, I'm going to move this, but we are going to now recall all of these angles. So cosine of 45 is root 2 over 2 times cosine of 30, which is root 3 over 2, plus sine of 45, also root 2 over 2, times sine of 30, which is 1/2. Okay, cool. Now I'm just going to do some math. This is now just algebra. I'm going to multiply these together. So when I multiply my radicals, I have to multiply the insides. So root 6 over 4 plus root 2 over 4, which I can rewrite. I can actually just leave this. This is actually the answer, guys. I personally, if I can, I like to rewrite it as one fraction. You might be curious why we can't just combine root 6 plus root 2 and make it root 8. It doesn't work like that. This is like having x plus y over 4. Cannot combine the x plus y, cannot combine different radicals. So that's it. We're going to go through a few more examples of applying this formula, and we'll be good. Let's go on. Number 2 is 105. So you got to be creative in figuring out which two angles can I add together or subtract to get 105. Okay, well here I would say this is equal to cosine of 60 plus 45, because 60 plus 45, sure enough, is 105. Using the formula, we have cosine, cosine, sine, sine, and there's going to be a minus in between since this is a plus. So cosine of 60, cosine of 45, minus sine of 60, sine of 45. Recall the unit circle. Cosine of 60, 1/2. Cosine of 45, root 2 over 2. Minus sine of 60, root 3 over 2. Sine of 45, root 2 over 2. Okay. Multiply. This on the left is root 2 over 4 minus root 6 over 4. You are going to have a lot of answers that look like this with the root 2 over 4 and the root 6 over 4. Okay? And you could make that one fraction like I did in the last problem, root 2 minus root 6 all over 4. Doesn't matter to me. All right, next one. Cosine of 165. Now we really got to think. All right. What can I add together to make 165? This is a little bit harder. I came up with this, and there is more than one way to do this. So it's not just my way, but what I came up with was 120 plus 45 is 165. Yes, 120 is in quadrant 2. The reference angle is 60. So yes, you still need to recall the entire unit circle for these problems. I know that it's super fun, but you guys are totally capable. Using the formula, cosine, cosine, sine, sine. Cosine of 120, cosine of 45, minus, switch the sign, sine of 120, sine of 45. Okay, cosine of 120. The reference angle is 60, so cosine of 60 is 1/2, but we're in quadrant 2, and in quadrant 2, this is negative. X is negative, cosine's negative. So we have negative 1/2, cosine of 45 is root 2 over 2, minus sine of 120 is still positive, so that's root 3 over 2. Sine of 45 is root 2 over 2. Okay, multiply. We have negative root 2 over 4 minus root 6 over 4. Again, I told you this root 2 over 4 and root 6 over 4 is repetitive in the answers. One other way to write this is negative root 2 minus root 6 all over 4. Last one over here. Let's see, cosine of 75, I would do 30 plus 45. Using the formula, expanding, we have cosine of 30, cosine of 45, switch the sign, minus sine of 30, sine of 45. Okay, cosine of 30 is root 3 over 2. Cosine of 45, root 2 over 2. Sine of 30, 1/2. Sine of 45, root 2 over 2. Multiplying, we get root 6 over 4 minus root 2 over 4. And we could leave it like that, or we could also do root 6 minus root 2 all over 4. Again, super repetitive answers. But that's it, guys. I hope that you're thinking, okay, not so bad. Let's go on and see what else there is. All right, getting into when we have radians. I'm just going to be honest with you guys. I actually think it's much easier, instead of trying to memorize, again, all of the radians and all of the degrees, I think it's going to be quicker for us to actually convert these to degrees. And then go from there. So just as a reminder, to convert from radians to degrees, we have pi over 12. You want the pi's to cancel, so you multiply by 180 over pi. 180 divided by 12 is actually 15 degrees. So this is equal to cosine of 15 degrees, which is the same problem that we've already did. This is the same as number 1. So the answer is the same as number 1. I'm not going to redo the problem. It's root 6 plus root 2 all over 4. Let's practice converting and doing the problem for number 6. Again, I just think it's easier to convert. Do you have to? No. But then you'd have to memorize all the radians over again. And I'm really thinking it's going to be easier for us just to convert every time. So 5 pi over 12 times 180 over pi. Pi's cancel. Let's see, 180 divided by 12 is 15 again, times 5 is 75 degrees. So this is the same as cosine of 75 degrees, which we already did as number 4. So it's the same types of problems. Oops. Same types of problems. I'm going to say see above. I'm not going to redo the whole problem, but the answer is root 6 minus root 2 all over 4. Moral of the story, if you're given radians, convert it to degrees and do what I did on the last slide. All right, let's go on. Now, I love these problems. This is working backwards, recognizing right away. If you see this, you might be like, oh, shoot, I don't know what to do, but hey, that kind of looks like that formula. Look, guys, this is angle A, and it's cosine, cosine, sine, sine, same angle A, same angle B. So I'm going to work backwards on this problem. This is equal to using the formula of cosine of 87, don't forget to switch that sign, plus 93. Okay, well, what is 87 plus 93? This is cosine of 180. Awesome. Thinking of the unit circle, 180 is at the point -1, 0. Cosine is my x value. This answer is just -1. Wow. Same thing with the next one, guys. This is, I'm noticing cosine, cosine, sine, sine, A and B are the same, so I can rewrite this as cosine of 60 minus, switch the sign, 15, which is the same as cosine of 45, and cosine of 45 is root 2 over 2. And I'm done. Love those. Okay, guys, believe it or not, the next page of the notes actually is for day 2. So that's everything that you need to know for your homework for day 1. This was a great day for me to miss because I really feel good about the formula. I think you guys can nail this, all right? I'll come back and go through any questions you guys have, but hopefully this sits well with you. It's not as bad as the verifications, at least I hope. One thing I want to point out for you guys is that on your homework, there are some negative angles. Do not freak out, okay? This example, this is number 6 from the homework. You can easily do this. Cosine of 45 minus 60. Who says that the bigger angle needs to come first? 45 minus 60 is -15. And then I can go ahead and expand and say, okay, so this is cosine of 45 times cosine of 60 plus, change the sign, sine of 45, sine of 60. So we got root 2 over 2, cosine of 60 is 1/2 plus root 2 over 2 times sine of 60, root 3 over 2. So we got root 2 over 4 plus root 6 over 4, or root 2 plus root 6 all over 4. There you have it. So don't be afraid of the negative angles. Guys, that's it. So why don't you go to your homework right now, finish that up, and we'll regroup tomorrow. See ya.